Hey everyone, today's lesson, it's a combined lesson, lessons 44 and 45, and we're going to continue with some work using decimal numbers. We're going to be simplifying decimal numbers, comparing decimal numbers, and then also starting our work with dividing decimal numbers when you have a decimal in the dividend place. So you're dividing a decimal number by a whole number. We won't get into the work of dividing when your divisor is a decimal. That's a mouthful. Anyway, you'll see. We're going to go through some slides together today. A lot of learning targets. I'm going to take a moment to talk through these. Simplify a decimal number by removing the extra zeros at the end of a number. Those zeros at the end hold no value. So when there is a reason for using those at some point in time, like when we're comparing. But in the end, when you're writing your final answer, those zeros hold no value. So just like when we do fraction work, we simplify fractions always. We simplify decimal numbers by removing any zeros at the end of the number because they hold no value. Attach extra zeros at the end of a decimal number to help compare them. I just said that. And then order decimal numbers from least to greatest. Again, a really helpful tool is adding zeros in there so you're able to compare them so you know which are least or greater, or less or greater, I should say. And then down here we have divide a decimal number by a whole number. Again, zeros at the end, hold no value. This will be good notes. I'll attach these in Google Classroom. Let's take a look at this example though. Multiply 25 hundredths by 4 hundredths and simplify the product. Please pause your video and give this a try, keeping in mind when I say simplify the product, I mean get your final answer and then rewrite your final answer with no extra zeros on the end. Unpause your video when you're ready to check my answer. So I've unpaused my video partially through this right here just to continue to talk through this work with you. This is a lot of zeros to look at, and this is a math problem that could potentially take me like 10 minutes, but I'm going to shortcut it by looking at this trick. 25 times 4. Let's look at the counting numbers we have involved. 25 times 4, well, of course, you probably think this too, but when I think of 25s, I think of quarters. 25 times 4 is 100, right? So I'm just going to get that down, 100. Now let's take a look at our decimal place value. I'm going to go back to my original problem and look at my factors and find out where my decimal needs to go in my product, in my answer here. I have 1, 2 decimal places, 1, 2 decimal places. So I'm going to start at the back of my number and count back. I have a total of, where's my camera? 4 decimal places I need to count back. So I'm going to start back here and say 1, 2, 3. I need to go one more, 4, and put my decimal here. That left me with an empty spot right there. That means anytime in a decimal answer I end up with an empty spot, I need to fill it in with a 0. And anytime in a decimal problem where I end up with a decimal here and there's nothing in front of it, I also need to add a 0 there. We're not done yet. Keeping in mind that simplifying means I'm getting rid of those extra zeros on the end. Now that I've filled in zeros where they need to go, I can also chop off zeros on the end because they hold no value. So I have this number here. Now that I've done this, I can actually cut that off, and my final product can be written as 1/100th. Okay. Let's look at comparing two decimal numbers. In this case, it's really helpful to know that you can add extra zeros to a decimal number in an effort to compare them side by side. So I have a decimal number here that just goes 1 decimal place value past the decimal, and then this one goes 3 places past. What I would suggest doing in this case is actually just rewriting this number so it is the same length as this number. I'm just going to rewrite it. I can add zeros. It's not going to change the value of it. It's just going to change how it looks. I can add 2 more zeros to the end of this. It's still the same number, but now it's the same size as this one. So just like when you check, when you're trying to alphabetize a list of things and you literally go letter by letter by letter, you do the same thing when comparing decimal numbers, or any numbers actually. We're going to go number by number by number until we determine one is greater than the other. So let's do that. We've made them equal size, so now we can work with them. In front of the decimal, I'm just going to cross this out. Well, yeah, I don't necessarily need to. I'm going to be looking at this number up here, though, that I rewrote. So I have a 0 in front of the decimal. So far, they're the same. Let's go one place past the decimal now. I have a 3 and a 3. Okay, so far, still, they're the same. One more place value, 2 places past the decimal. I have a 0 and a 0. Still the same. Keep going. Third place past the decimal. I have a 0 and I have a 3. Ding, ding, ding. We've determined one is greater than the other. 303 thousandths is greater than 3 tenths, I guess, or 300 thousandths. You read this symbol right here as less than. Another skill, very similar way to apply these skills, but just another skill in particular, is to arrange these in order from least to greatest. And really, when we're doing that work, we're comparing them, right, to determine which one's greater than the other. So please pause your video, give this a try on your own. As you're preparing to compare these numbers, you should be plugging in zeros so that they're all the same size, the same length past the decimal, and then you're going to be able to order them easily. So unpause when you're ready to check my work. I wanted to show you something quickly before I continue to do any more of my work. The first thing I considered was, well, how many places past the decimal is my greatest, is my longest number? What is the greatest number of places past the decimal that I have to work with here? And then I'm going to make sure every single one of these numbers is rewritten to show that many places past the decimal. So they're easy to work with. So when I looked at that, I noticed that my largest or my longest numbers were 3 places past the decimal. That's why right here, I've rewritten this number as 0.300 or 300 thousandths, 3 places past the decimal. I'm going to repause and do a little bit more work so I can shorten our video a little bit. Okay, so I'm ready to start ordering these least to greatest. I have them all written in a form that goes 3 places past the decimal, or what we would call 3 decimal places. And let's just start this work. I noticed that in front of the decimal, in the whole numbers place, I guess, or in the ones place, we have 0, 0, 0, and 0. So far, all the same. Let's look in the tenths place, 1 place past the decimal. We have 3, 0, 2, and 2. So far, this one is the least. All right, we have 3 numbers left to work with. We're going to look at the second place past the decimal, the hundredths place. We have actually, sorry about that. I'm jumping ahead of myself. We're still looking 1 place past the decimal in the tenths place. We've just determined what's the smallest right there. So we're not done with that place value yet. We've just determined the smallest. So let's keep going from there. Now in that tenths place, 1 place past the decimal, we have a 3, a 2, and a 2. Okay, so if we're looking at smallest, it's one of these 2 numbers here because they both have a 2 in the tenths place. Now is when, since they both have a 2 there, we need to move to the next place value, the hundredths. This one is out of the question, and actually we've determined because there is a 3 in the tenths place, that one is actually going to be the greatest. All right, there it is, in the greatest place. Now I have to determine which order these 2 numbers are going to go in. So they both have a 2 in the tenths place. Let's move on to the hundredths place. We have a 4 and a 3. Ding, 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 tells us right there. This is the less of the 2. This is the greater of those 2 numbers. Wanted to point something out really quickly. Notice as I rewrote my numbers in order from least to greatest, I wrote them in their original form. So even though I rewrote them, adding some zeros where needed and in order to compare them easily, I rewrote them all in order from least to greatest in their original form. For example, 24 hundredths, I added the 0 there, but when I rewrote that number in order, I left that 0 out. All right, so we're going to do a little practice with dividing a decimal number by a whole number. And I just wanted to pause here for a moment to remind you, oftentimes in working with dividing a decimal number by a whole number, we're talking about money. And these are two different problems right here. The only difference between these two is that this one involves a dollar sign. So keep in mind when you are dividing money, that's a label. And it's really, really important to include those labels in your answer. When you're working with money, make sure that that dollar sign comes up. Otherwise, the operation, the process of doing that division is exactly the same. So 2 and 25 hundredths divided by 5. Well, when you divide a decimal number by a whole number, your decimal does not move. It literally moves right up into your quotient, right up into your answer. So your decimals here, you can bring up your decimal right here. Both of those problems, part of your work is done. And actually, if it were me, I might even bring up my dollar sign so I don't forget. Can 5 go into 2? No, it can't. I need to hold that place with a 0. Can 5 go into 22? Yes, it can go in there 4 times. 4 times 5 is 20. 22 minus 20 is 2. I'm going to bring down my 5 because I have a place left to hold here. Can 5 go into 25? Of course. 5 times. That is 25. My writing's getting really small. And 0. So in this case, we have 45 cents, right? Because we're talking about money, 45 cents. And in this case, it's the exact same problem, but we're not talking about money. Our digits are going to remain the same, but we are not going to read this quotient as 45 cents. We will read it as 45 hundredths. Okay. So this is another example exactly like the one I just showed. For the sake of a long video, I'm going to skip past that. I'm just going to do this quick example. This is a little bit different because we have a 0 in front of the decimal, I guess. Go ahead and give this a try on your own and unpause when you're ready to check my answer. All right, so all I've done so far is brought my decimals straight up into my quotient. Remember, in doing this work, there will be oftentimes you need to plug in spaces or hold places with zeros. So can 3 go into 0? No. Hold that place with a 0. And then we'll continue on into our problem. Can 3 go into 2? Still no. Hold that place with a 0. I'm going to extend my division bar here a little bit. Now, can 3 go into 24? Yeah, 3 times what is 24? 8. And 3 times 8 is, in fact, 24. 24 minus 24 is 0. Our answer is 8 hundredths. We're not dealing with money or anything. There's no other labels involved. I'm going to stop there. There are other examples involved in these slides. Those will be available for you in your notes if you'd like to